Hey guys, it's Drac and we're doing the mod guide. This should be the Ultimate Nerf mod guide for the Elite Stryfe. I'm also going to be doing my first mod guide with the video goggles. We'll see how that goes. I should be able to use both of my hands while I'm working and looking down, so that should be really clear and really cool and give you guys a great perspective of like what I'm doing, especially because there's some circuitry involved in this blaster, which I know is complicated to people who don't work with circuitry. Also, I was playing around with my stockade and I took the stock off of the stockade and I put it on the Stryfe, and I finally decided what I want to do for the aesthetic mod here, and it should be really cool. I haven't decided if I'm going to put it in the title and give it away or if you're going to have to watch the video to find out. But I haven't done a replica blaster in a while, and this looks perfectly suited to be a replica blaster for my favorite video game series. So we're going to turn this into something really cool. We're going to do the actual modifications first so that the video is pertinent to everyone, and then we'll do the aesthetic second, but it should be a ton of fun. Alright guys, so obviously you take all of the screws out of the blaster. They're all Phillips head screws. A number 1 or number 0 Phillips head screwdriver will do you just fine. All of the screws are the same size except for the ones here and here. They are just a smidgen smaller, to the degree that it probably wouldn't even be a big deal if you get them mixed up, but if you're putting it back together and you're wondering why 2 of your screws are smaller, that is the reason why. So after we butterfly the blaster open, we see that painting is going to be a breeze because these pieces are separate and the shell is really easy to work with. Now inside we see that we have some resistors here, some electronic locks here, and then another one down here, some mechanical locks here, and then there's a mechanical trigger lock here, and then up here, this is the lock that's giving everybody a ton of trouble. It's actually the easiest lock to remove. If you do nothing else to your Stryfe, you should do yourself the great service of coming in and noticing that if you can pull the trigger, which you have to have both of these locks pushed in to do, I think, this will stop you unless you have a dart in, and it's the make sure your blaster is loaded lock. Now it is the worst lock because it prevents you from firing as rapidly as you possibly can. So whatever you do, remove this lock. It's really easy. That is the dart lock. Then you can come in, and I'm going to remove the internals because I have to paint it anyway, and my screwdriver is a little small for these, which is a shame. But I'm going to remove all 3 mechanical locks, and then I'm going to explain to you what I'm going to do to the electronics, and then I'll head in there and do it. Hopefully this comes out. Nope. The issue right now, the reason that these are coming out slowly, is because I'm using a number 0 Phillips head screwdriver, and I really should be using a number 1. I'm just barely gripping these Phillips head screws. Okay, so there's the dart pushing mechanism, very similar to a barricade. If you've seen my barricade video, you know exactly how that works. Now these should come out really easily. We're going to have to put back in the base for this lock, but the lock itself definitely has to go. And this gives us access both to the mechanical lock and... Alright, so here's our mechanical lock. We'll remove that, and then underneath it, here we have one of our electronic locks. They're actually really nice switches that come with these Nerf blasters. You should definitely hang on to them and use them for other things. I've used them in robotics before, like college level robotics competitions. I've used these locks from Nerf blasters and they work just fine. They're great switches. We're going to go ahead. This actually doesn't need to come out, so we'll just come down and we'll remove the rev lock. I may actually keep the rev switch in this one and just add an LED, but I'll do that later in the cosmetic video. Decided to make the cosmetics video an entirely separate thing. So here's this switch here, and we're just removing this piece. Everything else is going to have to go back in. So keeping all of that in mind, these are all of the locks. We want to keep this exactly how it is. These are the electronic locks, in a sense, here and here, and extra wire length is actually a resistor in and of itself, but the motors over here have resistors built in, and hopefully it's as simple as removing these 4 black screws to show you those resistors, but we'll definitely be cutting those out and bridging them. We could actually just connect them and leave the resistors in there because current will follow the path of least resistance. But okay, so we're tethered in right now by our little wire protector here. No big deal. So we're almost entirely gutting the blaster to get at this. Alright, so there we go. Here's our electronics. We're going to end up cutting all of these out and leaving in this one switch down here as a rev switch. And then over here we have our resistors. The resistors have been shrink wrapped, which is a little frustrating, but we're going to end up cutting those out entirely and then rewiring these motors in parallel. So I'm going to go ahead and cut the video, and I'll show you kind of what all of this looks like after I've put it back together. Alright guys, so any good craftsman will tell you that the difference between something that looks great and something that looks poor is sanding. It all comes down to craftsmanship, whether it's like robotics or jewelry or Nerf. Like, sanding makes the difference between something that looks really nice and something that looks really poor. And I've shown it before in my videos, but I want to show it again. The real trick is to use power tools when you can and then go by hand to get that fine finish. So I've got my Dremel hooked up. I'm going to set it to about 20, I feel, and then we'll see how that works. I'm obviously not going to do all of these pieces because some of them have labels and some of them don't, but we'll start right here with the battery door. It's got the Nerf Elite label, and what I'm going to do is I'm going to start with this. This is a grinding bit. They look like this, and this one's in pretty bad shape. They're both actually in pretty rough shape. I need to get some new ones pretty soon. And then I move to a sanding wheel. This is an 120 grit sanding wheel. All this is inside here is bunches of little pieces of sandpaper attached to a wheel drum. And then this is a sanding sponge. It's a much finer grit, and I will use that last. So I'm going to go through, show you how all of this works, and then I will jump to the next segment, but I'm not going to do all the pieces. I'm going to show you how one label gets sanded off. Way too fast. Switch it to 12. Alright, so you can see there that all I've really done is knock down the embossed nature of the logo. And now I want to even that out and get it more level, and then I'll use my sanding sponge itself to even out and polish the surface. Alright, so I'm hoping that you can tell on the goggles that that's getting really smooth and you can no longer tell that there was a logo there. And then I just come in, and this not only roughs up all of the shiny surfaces that are left behind by the injection molding that make the plastic resistant to paint, but also evens out all of the sanding that I've done previously. So like, I'm pretty pleased with this. After I come back and I rinse it off to get rid of all the dust particles, this should be ready to paint. Alright guys, so we're recording, and this segment's actually really important because it's the first time I think I've ever done soldering on screen, and I can show you guys how that process works. Now obviously I want to talk about the lock removal first. We've removed all the mechanical locks in the blaster. This one's gone, this trigger lock is gone, and I've replaced all of the panels. You can see that I've also sort of started my paint job. And it is painted, but I don't want to show you the finished result yet. So everything's done. A lot of people are afraid to paint pieces like this because they're moving parts. I've explained time and time again that it's very simple to paint these parts. All you have to do is be wary of the fact that they're painted moving parts and grease them before you put the blaster back together so that there's a little bit of lubrication to prevent your paint from chipping and scratching, and it'll last really long and look really nice in that fashion. Now over here you see that I've taken the circuit, I've removed all of the resistors, I've replaced it with wiring. I also went ahead and removed these rubber bumpers just because with a soldering gun there's a chance that I might tap them, and I don't want molten rubber all over my soldering gun. You can see that my soldering gun has seen much better days. This isn't supposed to be bent, and it only has really active surfaces right around here. The tip doesn't work nearly as well as it used to. Now that said, I've gone on and I've taken needle nose pliers and I've stripped a portion of the wire. This is my lead. Before I solder this down, I'm going to prove that my circuit works so that I can check it. And if I'm running out of hands here, if I tap like this, yikes, you can see that, wow, that's hilarious, my button popped out when I dropped it. Circuit works fine and all the leads are live. So I'm going to take this, wrap it around here, and kind of crimp it with my pliers. So this is what I want to solder down and lock down. And as long as it's soldered down, I won't need any sort of like shrink wrap or tape or anything. It should be very secure. So I'm going to take my soldering gun and heat up the wire underneath, trying to hit this lead right here. I'm coming in, this is lead-free solder, which is good because it's less likely to kill me over time, but lead solder works just fine as well. I'm going to start melting my solder to the wire. I like to err on the side of plenty. You can see there that I've got my solder flowing. It's no flux solder, it's really easy to use. And you can see, it's still a little hot, but it cools very fast, that this is never going to go anywhere. Those two wires are now one deal, and that's really important. I have one more lead over here, so I can do it twice, which is great. Or my camera wants to die. We'll see if we can get through the entire segment. Hey guys, so this is the finished stryfe. It's now what I think I'm going to call the SMG from Halo 3. I know that the SMG has been through a lot of different permutations, but I think it looks like the SMG. It's worth mentioning that all the batteries in here are now Trustfire batteries. They say it on them, but I don't want to find it on them that they are 3.7 volt output, which means that they are over double the original 1.5 volt that a standard Duracell Energizer battery has, and they're still the same AA size, so it makes the voltage mod really easy. We're outputting twice as much voltage, which means that the motors are spinning much faster, not only because they no longer have the resistance that they have to go through, but also because of that voltage increase. So the blaster, in addition to having a higher rate of fire because it no longer has the dart checking mechanism and any of the trigger locks, also shoots a lot farther, which is really important. I also did up the stock. That's when it looks like an SMG, I think, is when it has its stock. And I think that that's kind of what the SMG from Halo 3 looks like. I think it's really, really cool. I went ahead and I did all of the little details that the Halo 3 SMG has. It says M7 caseless, and then I don't know how to pronounce this because I've only read about it in the books, but it's Misraya Arms, which is how that's spelled. And we have UNSC on the other side, which of course is the big Halo army. The clip also says UNSC on it. The rev switch still works. The clip release is still super smooth. I really like it a lot. I think that everything on this blaster is much smoother and easier to function. Obviously I need to sand this down or put on an orange barrel attachment of some sort if I want to use it outside, because it is now very realistic looking and very not safe. That said, it is a really cool replica prop blaster. I really like the stryfe with this stock on it. I think that the stock is sweet, and I think that this is a full clip. I've got another one here, so I'll go ahead and fire it off and show you how it goes. But the ranges are improved because of the voltage mod, and the rate of fire is significantly higher. The rev up time is also a little bit less. All of the mechanisms are just a lot smoother. I'm really happy with how this entire mod turned out. I hope that you guys liked it too. It's just remarkable how quickly I can go through all of those darts without any of the locks to get in the way. It's just really, really cool. I think that the stryfe is the epitome of what this clip-fed flywheel blaster should be working towards, and that it's compact, it's small, it's easy to mod. The voltage mod was easy. All of the circuitry wasn't all that complicated, even without a soldering gun or much knowledge of what you're doing. It's a really great first project to just kind of tinker with all of this stuff. I think this blaster is sweet. I may install a tactical light up here where the rail is, but like, I think it's pretty much done. I'm very pleased with how it turned out. I hope you guys have enjoyed the video. I think this is a great mod guide for the stryfe, and I think it's a really cool little cosmetic mod that I've done up. So that's the Halo 3 SMG, and as always, thanks for watching. I guess I should have made two of them, then I could dual wield. Huh.